Hi. I am. A beer. How are you? I am fine.
What you just witnessed was the real demonstration of SignBridge V2's capability. And today, I, Abhishaha, am here to showcase this very project in front of everyone. So, SignBridge V2 is the first web-based AI-powered real-time two-way sign language classifier that aims to bridge the communication gap between the hard of hearing people and the hearing community via computer vision, machine learning, NLP, and AI. So, how this project works is that first, the browser's client sends us using their webcam feed loads the MediaPipe WASM API from Google, which extracts 21 landmarks of XYZ coordinates and sends it to our first ML API backend. What it does, it normalizes the landmarks. What that means is that normally MediaPipe uses the Z for depth, whereas the model trained on images uses Z as another coordinate points. So we normalize this, then feed it to our random forest classifier with 100 trees, the already pre-trained model, and this returns us two things. One is this predicted sign, and the other one is the confidence levels, and that very sign is shown in this buffer. And next is, it has 3 plus 5 timing, that is 3 seconds for the website to load everything and 5 seconds for the user to show another sign before it auto submits to our backend. This is the second AI backend that is responsible for automatic grammatical sentence logical reconstruction. What that means is that this sends our HI individual signs to ASI1 LLM API to get proper logical sentences. So your H and I signs together become high with an exclamation. Then this formed sentence gets sent back to the web page and is shown in this AI translation area. Next, via T2S, and next, as soon as it is shown, T, uh, TTS starts, that is text to speech, and for the hearing user to also hear it. And similarly, on the contrary, for the hearing user, it is that the microphone, the hearing user speaks in their microphone, and via the web speech API, we do STT, speech to text, and show it in this speech input area for the hard of hearing users to listen to it. Now, if I go over to the text like area, The front end is built with React 19, Vite 8, JavaScript, vanilla CSS 3, and HTML5. For the ML area, I have made a special open-ended ML API for everyone to access it. I will show it in a bit later. It runs on Python 3.11 with MediaPipe, scikit-learn util, OpenCV, NumPy, and FastAPI. The backend for the AI routing is followed by Next.js, Next.js, and for the extra infrastructure, it is Lucid Icon for all these beautiful icons and MediaPipe. So all of these are hosted in Vercel, and if I go over to the ML API, it would be kind of like this. So how the ML API works is that where is it? Yes, is it? So how the ML API's system architecture works is that first the client sends us the exact landmarks via an HTTPS post request at the classifier. Then our first API routes is to the normalization util via the sign classifier PLK and gives us the prediction and the confidence level in a JSON response output, which gets fed back to the client for it to be showcased. And these are all the documentations and stuff. Now if I go over to the results of this very ML classification model evaluation, this model is trained on the merged data sets of Kraggle's two independent data repositories, evaluation with a total of more than 1 million images for training, and similarly and with an 80-20 separation for training and testing. This is the cross validation of all of this. You can see the overall accuracy is with a staggering 99%, and it is not just only for saying this. These are actual facts. If you go over here, this is the confusion metrics. This entirely shows this clarity of how our model isn't not that bad. This is the feature importance. This shows the how top 10 landmarks are properly done. Now if I go over more to the SignBridge one, about the overall project pipeline, working pipeline. Wait a second please. Okay, so this is the sign to speech pipeline. What it entirely does is that please wait a second. It seems that there is a bit of problem from GitHub side actually. It was unable to render it. Okay, so here are we again. So okay, this is the sign to speech pipeline. First the deaf users show us ASL hand signs via the camera, then we clock it at about 15 fps for a proper viable experience for even low-end devices. We send it to MediaPipe. We extract 21 landmarks via and send those landmarks to our ML API via post/classify, which then gets normalized and gives us another fetch request with the sign and confidence levels. Then it enters the sign buffer. We have 3 seconds idle and 5 second countdown for another thing, and then it just sends another post of these signs to the API SignBridge backend for grammar reconstruction via ASI1 LLM. And then we, after getting this reconstructed one, we send this to the speaker via the web speech API for text to speech. And similarly for the speech to text, it is the same. The hearing user speaks naturally in the microphone. The audio streams goes into web speech API and gives real time transcription, and that transcription is displayed for the deaf user to read. And this is the ML training pipeline. If you see here, this is the ML training pipeline. We first do we use to merge, as I've said, the Kaggle dataset. These are all image collected. We extract MediaPipe landmarks over a 21:3 coordinate vector and normalize and center every image. Then we train and test on the 80-20 using a random forest classifier with 100 trees, and this gives us a file of sign classifier.plk about 31.7 MBs. And this is accessed by the FastAPI, and this is for the development and whatnot. Overall, if I go over to this project, and this is the roadmap for now. This is what we have done, and more will be done later on. First, now this is built for the ASI 1 hackathon, and today I'm here showcasing this very thing. So now if we go to the real, if we come the real area, what challenges I have faced and what I have learned. I have learned a lot of things, mainly the entire full stack part. And the challenges, biggest challenge was working on a not so great of an hardware. I'm putting up this state, my hardware isn't the greatest, nor is near even comparatively to any powerful. Even this small conversion of from landmarks, from images to landmarks, took me 7 hours to complete because of the large amount of dataset size, accumulating over 1 million images. So well, this is all what I have made for this hackathon, and I hope that this SignBridge V2 finds helpful even to someone who is facing any kind of problem. Let us all thank that everyone is differently able, no one is disabled, everyone has their hidden potential, no one is separate. And with that, I would like to end this very showcase. Thank you and have a nice day ahead. See ya. I am out.